Alright, what's up guys? In this video I'm going to pick up some more differential equations, and then today we're going to be talking about third order linear homogeneous ODEs. So we're asked to find the complementary solution to the given third order linear homogeneous ODE. Y triple prime minus 3y double prime plus 2y prime is equal to 0. So basically the way that we find the complementary solution, by the way, complementary solution is just another way of saying general solution. Some people say general solution, some people say complementary solution. But basically the way that we find the complementary solution for the higher order or the third order linear homogeneous ODE really is no different than how we do it for the second order one, which I showed you already in a video. We simply identify what the auxiliary equation is, or we write down our auxiliary equation, also known as the characteristic equation. Some people say auxiliary equation, some people say characteristic equation. And then once we write that down, we then find the roots, and depending on what kind of roots we have, our final answer will take a certain form. But we really solve this no different than we do for second order equations. And what I'm going to do in the next couple of videos, I'm going to post a video of solving both second order non-homogeneous ordinary differential equations, and you can do that basically two ways. You can do it by using the method of undetermined coefficients or variation of parameters, and remember, for the non-homogeneous ODE, and I'll talk more about that in another video, but that's just a combination of the complementary solution and the particular solution. So we'll talk about that in another video, but I'll post a video on that. So let's write down the auxiliary equation for this third order homogeneous equation. Okay, so if you've seen my video for second orders, then you know how to do this. This just becomes r third minus 3r squared plus 2r is equal to 0. That's the auxiliary equation. I'm going to factor out an r from this left-hand side over here. So when I factor out an r, I'll have r times r squared minus 3r plus 2, and I'll set that equal to 0. And you can always check whether or not you factored something out correctly by distributing it back in. Notice if I distribute the r back in, I'll get the r cubed backed out, I'll get the r squared, and I'll get the plus 2r. So that is factored correctly. So we know here that r is going to be equal to 0. And now we need to set r squared minus 3r plus 2. We need to set that equal to 0 as well. Now let's factor the r squared minus 3r plus 2. Well, I can just write that as r minus 1 multiplied by r minus 2, and you can validate whether or not I factored that correctly by foiling those two. Now I'll set those equal to 0, so it'll be r minus 1 multiplied by r minus 2, and we'll set those equal to 0. So we know that our roots are going to be real and distinct, so r is going to be equal to 0. I guess we could say r sub 1 if you want to, will be equal to positive 1, and we could say that our third root will be equal to positive 2. So since the roots are real and distinct, we already know what form our answer is going to take. So the complementary solution, that's just y c of x. And now we just stick in our information. So remember, c1, c2, c3, those are arbitrary constants. Then it'll be e raised to the 0x. That'll just be, I'm just plugging this in. This is just reduced down to just c1, because remember, e to the 0 is 1. So that'll change in a minute. I'm just kind of writing everything down so you can see it. Then this would be plus c2 e to the 1 times x. And then this would be plus c3 e raised to the 2 times x. And then when we write our final answer, we can write our complementary, we'll get our complementary solution, also known as the general solution. So the complementary solution for this third order equation, so complementary solution will just end up being y sub c of x is equal to e to the 0 is 1. Keep that in mind. So that'll just be c1 plus c2. C2 times e to the 1 times x is just c2 times e to the x, obviously. And then this would be plus c3 e to the 2x. So that's the complementary solution, and that's your answer. Now the reason why I want to do a lot of videos on these, because in order for me to show you how to do the non-homogeneous or solve the non-homogeneous second and third order ODEs, we have to know how to find the solution to the homogeneous equation, because again, the solution to the non-homogeneous ODE is a combination of the complementary solution and particular solution. So that's your answer to that. So let me know if you got any questions about it. I'll be more than happy to discuss it. So I'll see you guys next time. Y'all take care.